Hello and welcome back to all my refactoring tutorials. So this is the second to the last video in the series of refactoring. So far we've kind of gone over a couple of ways that you can refactor your code. We went over the idea of shielding all your changes with the unit test. Then we looked into changing the behavior of the actual code we'd written. We increased the readability, we made it faster, and now we're gonna do moving something somewhere else. So this is a possibly complex topic to discuss because you could actually do this for a multitude of reasons, and you can do it in a lot of different ways. So the two ways that we're going to discuss doing it today are kind of changing a function to extract something that you're doing, some code flow out of that function and putting it inside the same class. And then we're going to talk about taking some function and then moving it completely outside of the class and making it kind of like more globally exposed. So, just because you take something outside of a class doesn't mean that everything can have access to it, but sometimes you might do that just so that other files in your system can have access to that same code, right, without you having to rewrite it yourself in a whole lot of other places. So, but yeah, I can imagine you doing something like this for a lot of different reasons. And, it's like, you may decide that you actually want to change a data type here, and that might change some of the functions that you call inside of here. You might not call a for each loop on a name anymore, or you might not treat it like a string. So as you kind of add functionality inside of your classes and you make more complex things, you'll find yourself using variations on this technique. As you introduce new classes in different areas of your code, you'll come back and you'll probably do something like moving something somewhere else, right? So it's, if you built something in a different location and it happens to optimize something that you've done here, well, then that was an example of moving something somewhere else. You just never did the initial step of coding it out here. It's just that you kind of jumped that step. You instantly coded it out somewhere else, and you came here and took out a chunk of code to like kind of save, increase readability, and just kind of save yourself time for debugging in the future. So we're just going to kind of take this simple example of our class right now, this names parser, which right now the only thing it does is it parses names from a text file and it dumps names into a text file. So very simple names parser class. And so we're just going to kind of find a way, an example of something that we can do to just kind of extract out, and seems really generic. It might be something that something else could maybe use in the future. You'll have to excuse that. That is my rice maker. So what we have here is this for loop. So this for loop actually is very generic when you start to tear it apart. All it's doing is iterating through this list of names, which is essentially just a string. And so it iterates through this list of names and then appends this new line to the end of it until it gets to the last one, and then doesn't add a new line to that. So that's actually if you ever use like a Python, or if you use link inside of C#, that's very similar to joining the string or zipping the string with kind of some characters on the end of it. I think JavaScript has it too. So, we kind of just recreated that function here, and maybe, you don't want to kind of like add a whole new library just to get that one little function in there. So you just code it up yourself, but then you say that, well, some other code can probably use this too. So let's just pull this out for now, and just make it something that's only accessible to things inside this class or things that inherit this class. And we'll just kind of pull it out down here as a private method. So we'll make a private method. It will keep it static because we want it to be accessible by other static methods. And then it's going to return out a string because that's what we were forming at the end of all of this, name as string. And we're going to call this kind of I mean, there's a variety of ways that you could kind of you could name this, but I'll say we'll just kind of go with the nomenclature of join. So join with uh, and I'm just gonna make it new line. Some of the clever among you might be looking at this going, well, you say join with new line, but can't you just kind of pass in the new line as a delimiter, and then that way you can kind of give any arbitrary character to it? You absolutely can, and that would be a great exercise for you to do in the future. Is make this an even more expansible function that can take any kind of delimiter. So, and for those of you who don't know what a delimiter is you can kind of think of it as something that is globally known as a partition point. And so, when you look at a CSV file, it's kind of known that a comma is a delimiter to it. And what that means is that every time you encounter a comma, you expect that to be kind of a new column inside that CSV. So I'm reading, I get to a comma, then I know to stop reading and put that in as like one variable, and then make a new variable to contain the contents of the next thing until I get to a new comma there, and on and on and on. And so in our case, we have a text file with a delimiter that's a new line. And if I'm not explaining it well, there's lots of articles on this, but yeah, you'll see delimiter kind of come up a lot. You would use it, and I think, yeah, so here split is using a delimiter of a new line as well. And we just take that new line and we break up our entire string that we got in by that, and it spits it out into an array that was partitioned from all the new lines that it encountered, right? So you can think that every time it encountered that, it made a line and like gave anything before it like its own element, and then the thing after it gets its own element as well. So we're going to code out this join new line function. And like I say, we're not going to use any concept of a delimiter. We're just going to take in this case, we kind of have some options. We could take in a string array. We could take in a list of stuff. The thing I do know is that I'm dumping a list of names in here, and list has a toArray method that would actually be pretty easy to use. That toArray method is going to kind of spit it out as an array. So I don't necessarily want to wrap that in a new list. So I'm going to use a string array. But then I also know that it's going to come to me as a name, an array of names. So names array. And, oops. Brain lapse just there. Here we go. So names array. And like I say, no delimiter, but please take that up as an exercise in the future. And then, okay, so I'm going to get this names array, and I'm just going to say join with new line. And now I actually can do something kind of unique here, but we'll kind of talk about that maybe in the future. But I could actually just take this in as just a string, but then I know that I would have to end up doing some conversion work up here. What some people will do is they'll actually make something like their name inherit from string, right? So they'll make it actually inherit from the string data type. And so when they do something like that, you have to define a couple of more methods to make it fully but yeah, or you could interface it like a string data type, but so they might do something like that so that they could pass it in as this, or you might do something like an object array, and then you'll cast everything into a string, and with the assumption that whoever's calling understands that if I cast to a string and I for some reason fail, then you're gonna have to handle that exception. I'm not responsible for handling it because you knew due to some contract that you were only supposed to pass in a string array into my method. I just made it an object array so that you could pass me things that act just like strings. So we're not going to really do that because that actually introduces a lot of pain for us and for anyone calling that method in the future. This is very clear to us, and with some simple conversion work, we can kind of easily pass this to us. But we're gonna go with name first, and I'll just kind of show you. I'll kind of motivate why I was thinking like that in the first place, of why we really want this to be a string array. But anyway, so we take in this name of strings, and the work is pretty simple. We just copy and paste this here, and maybe we'll fix a few errors. So now it's a name array. It might not be .count anymore. It might be .length. We just take this, change that to length, and boom, just like that. Oops. Just like that, we are good to go. So we've duplicated the functionality from this function right inside of here. And so we can do this now. And this function actually just becomes one line, which is nice. So it becomes, we can just call it this way. So join with new line, and it will take, I always hate when it hides the thing I want. Names to dump dot to array. Alrighty, cool. And because we have unit test, all we can do is we can go right over here and run everything and make sure everything's running fine. Oops. Oh, those are some old tests. I don't care about that. All right, cool. So yep, all of our unit tests are passing. We can come down here, moving something somewhere else, dumping, then parsing. So, you know, it only has that file, that test, because we ended up figuring out that that was the only test that we needed, and it was a fully functional test all edge cases that we would care about, and you know, are all kind of known user cases that we would care about. Like this was a good enough unit test. We trust our unit test, and so our code passed all of that, and so we know that this refactor was successful, and so we can move on with our code. We could submit this to a PR and be done with it. But like I said, one of the things that I don't like about this is that it's not super extensible. So this works great within a names parser class, right? Because you're only operating against name objects. But what happens when something else wants to join with new line? That's a very common issue someone might have. So what would you do if you wanted to pull this outside of this class and make it something that someone else might want to use? Let's just say that they came in and they had maybe a pets object, I don't know, and they wanted to join, they wanted to output all the names of pets or all the names of an event, and they wanted to output all of that to a text file, and they wanted it to have new lines for each line. So how would you kind of change this function to be something that worked for that? So like I said before, we kind of had this option of we're just working with strings, and so strings work fine. We pretty much don't have to change anything in here except for this name thing. And then it's super extensible. We know that strings are going to concat well with a new line, and we're going to output to a string. So, you know, it's actually pretty optimal. No casting required, but then it requires a little bit of manipulation up here to make that work. So, you know, maybe we say we don't want to manipulate anything. We kind of want it to just kind of work. So, maybe you do something like this object, and then you try to do all the work with inside of here, because this is the thing doing all this work. And so if your object, each object had a toString method in it that you could call, then in that toString method defined the string and output it in a good way. So like I say, if we do something like this, you know, then that becomes another option too. You can even do something that's called templating, in case you've ever heard of that, And so we would be able to provide some type here when we call the function, and then we have some type array here. And similarly, it would be a toString. If you've never seen this one, the way that might look is it's just that when we call this method, we would call it with the data type that we're holding, right? So we have, oops, not type, but the data type that we're holding right now is name. And we would just tell it that I'm feeding you a name array. So names to dump dot, and just pop that to array. And then that's how that function would run. And it may or may not spit it out properly. It probably won't, because calling a toString on our names is actually not going to return what you would expect. But yeah, there's kind of a few ways that you could refactor this. This is actually my most common way of refactoring something, is to use the template function, because it tells someone right away, hey, I'm joining this kind of data type with a new line, and you know, I can most easily extend this. Like I say, this needs to go and define its toString method, so I don't even have to really inherit the string class, but depending on how well someone codes this function up, I would just have to go here and just define you know, public string toString method, and as long as, you know, this meets all the requirements, I need to add an override. I never placed the override correctly. It's very arbitrary. Okay, so cool. So I could come down here and I could place this override toString here, and then I get this return name. And then, like I say, so now the code ends up working just fine this way. But I'll tell you the reason why I don't like it for this example. The reason I don't like it is because there's no way for the compiler to tell someone, hey, go override the toString method before you use this function. And so for people that aren't used to kind of coding with your compiler, I always kind of say, and I'll make a video on this, but you always want the compiler to make the person fail to execute any code that they aren't supposed to, or code in a way that they're not supposed to. And, you know, let me just give you kind of an example of what I'm talking about. So if I come up here, I'm just going to go ahead and comment out the code that I just added right here. And I'm going to save. And I'm just going to go ahead and plug this in. Right there. Probably too many parentheses. Okay, cool. So I saved this in, I did the template way, and everything is looking pretty good. There's no squigglies, but we know that I don't have that toString method defined. And so why isn't it breaking? Well, objects by default have a toString method already defined. So it's never going to fail to execute this piece of code for us. And like I said, we can't, you know, someone might be saying, well, we know the type, so can't we just call the t.name? Well, is every type that you use going to have a t.name? I can't cast down to a less specific type in a template function. I would never want to just cast my template function to an arbitrary type. So I'm kind of relying on this object that's defined just by default in every object. And so is that going to cause any issues? It's a toString method and I'm trying to get to a string, right? Like, let's just run the test and see. Well, yes, now we see a failure. And here actually expected Janet, but actually got back this thing. And what is that? Well, it's just the representation that C# is by default going to give you when you just print out an object's toString, right? So you haven't overridden the toString method in that object to tell it, oh, hey, actually don't just pull the generic name for this new model that you've created, this new struct, actually grab one of the attributes that this model has. So when we override it, if we run this test again, all of a sudden we have success again. So that looks pretty great, right? We can go along with it. Well, now the problem comes when I make a new structure and I want to use this function with it. So if I just go out here and I make something called events, or an event struct, and I format it really similar to this, right? And I'll just kind of code it here just to show you what I'm talking about for visual people. Event, but like I say, I'm not thinking when I look at the struct name that I have to override this toString method. There's nothing telling me that you have to override the toString method. So I just code it out here and I just go on my merry way. And then I call the names.parser with now I try to join new line. And this time I try to join on event. And I try to do a dummy. That's going to fail. But anyway, I try to do this call, but I'm going to face the exact same issue that we just solved, where events gets interpreted as that weird generic naming for a C# class. But name is going to get interpreted just fine because we overrode the toString method for name, but we didn't overwrite the toString method of event. And there's, like I say, the compiler will never fail because it's okay to not override the toString method because it's defined by default for you for all objects in your code. So that's why I wouldn't like to use a template there without a lot more boosting by the compiler, and we're going to go into those reasons why. I don't want to get too down that rabbit hole, but there are ways to kind of constrain the types that go inside of here. So for people that maybe want to deep dive into that, you can put like a where clause here, and I'm forgetting the syntax, but it's like, yeah, you can do a where clause here where you can kind of limit the type of the T down to an interface, and then you could make everything that can use this that uses this function, they have to define some kind of that interface off of it. So if you would have eventually made something like, you would have said name, maybe you would make a interface called like parsable. I kind of like that name, parsable. Maybe I think that's how you would spell it. Maybe not. I don't know. But let's just say you had an interface called parsable, and this thing only took things that interface with parsable. So you could even do something like this. You don't have to leave it wide open as type T. You could just make it something like that. And so anything that inherited from parsable is going to be able to use this function, and then you can make parsable be an interface that required you to define some kind of method. So I would highly advise you not to require a method called toString. You might not even be able to, but because that's just going to cause confusion. But you might define your own kind of like output or representation function down here, and you would require that for all classes that inherit from parsable. And once you call that function, it's going to be able to call the function, once you come down here, you can now, instead of calling the .toString method, you can call some function inside of parsable that's going to give you a string back and work just fine. Like I said, that's very advanced. It is my default way of doing a lot of things, but I just think it's way too complicated for a situation like here. But I did want to introduce you to templates. It's totally fine if that flew over your head on your first watch of this. I would say come back to this a little bit later, and once you've gotten a few more videos down to just truly kind of understand why that might not have worked in this situation, and why you might want to do it a different way. So like I say, we're not going to do it with the template way. Instead, we're just going to try to do it either with a string array or an object array. So like I said, string array, super versatile and super clear to the person that, hey, I need to somehow get this thing to a string. Whereas with an object, a person might now have to deal with, oh, I didn't feed in the right types into this. I don't like the string method that it's calling, the toString representation that it's printing out. And so, it ends up with the person kind of solving a lot of things that the compiler wasn't going to catch for them. So I would say just define this as a string array. That way it's super extensible and people can use it with a lot of ease. So, and that just will have to be a rule of thumb that you take from me. Since this is a string already, we don't have to call the toString method. And I would advise that you would take that away because that gives you a little bit of compiler boosting, because we know that this is a string, whereas if we in the future change this to an object, we should, it's not failing now, but we might see more runtime issues in the future. That would actually throw an exception, whereas if you had it just as a toString, that's never going to throw an exception. It's just that you're going to have to see it as you're going to see the output and see that it was going to be that weird string representation, and those bugs can be brutal to try to solve. So try to help yourself out as much as possible. Make the compiler crash, make your code crash. You don't often hear people say that, but yeah, make your code crash. So we're kind of left with an interesting problem. To use this method, we need to give it some kind of string array. Now, I can hear kind of the groans. This looks like a normal kind of conversion problem, and absolutely, it does look like it is. There's lots of ways that you could tackle this. There's lots of clever ways to tackle it too. Like I said before, it can be really expensive to allocate memory for arrays sufficiently large. If this were an array of 1 million names, this just would be an unworkable solution for us, and we could see that this function would be something that we just wouldn't be able to call. So kind of keep that in mind. The refactor that I'm about to do does limit the scope of what we can do in the future, and certainly we would want to think about using one of the other options like the template function to kind of get around the space consumption that we're about to take up right now. But this is just, now we're going to start to assume that join with new line was an API that we never had access to. So it was always something that existed. So we're just trying to interface with it really fast, really quickly. We don't want to be unique. We have, array sizes that are less than 1 million. So it's totally fine to take the memory hit. And we're just going to convert our name list into a string array. So I'm going to come here and I will go ahead and make a string array that is equal to, the syntax on this is always brutal for me, var names as string will equal new string. I think it's, see now is it that? It changes like every single language. Dot count. Do you want a parentheses or a semicolon? Okay, cool. All right, so we have our array, empty array that's gonna fit all the names that we have. Like I said, this is the most expensive thing that we're doing. This could be super expensive. So like I say, by far, this is not the most efficient way of doing it, not the most best way to save space, but it's kind of the best thing that we can do right now to just kind of quickly move on and get through this problem. So we're just going to go iterate through. So we're going to actually want to use a normal loop. Equals 0, less than, let's do names to dump count, then I++, and then we'll say name as string of I will take names to dump. And names to dump has a nice indexing. Oops. Of course, I want the name attribute. So cool. So that should give us our array as we want. Then all we do is pass that into this function. We call our unit test again. Hopefully no off by one errors, and we are good. So that is how you would refactor to make that work. Like I said, this is ripe for more refactoring. Once again, I would leave that as an experiment for you. If you understood kind of my brief explanation of the templates, maybe you should go back and try to integrate this as a template function call so that you don't have to do this conversion code here. But that's pretty much the number one reason why people have kind of templates or very generic data types that they pass in, because they don't want to do any of this conversion code. They want to pass in all the data just as it is in the format that it is, and you know they want their library functions to be super extensible. So you'll even see people pass in a function here, which is like wild, right? They'll pass in some kind of function that gives a result, and it tells you, okay, this is how you are going to operate against this data type. And so it's an array of objects, and here's a function that's a required parameter, and that function just pretty much accesses the proper parameter outside of it. So there's a lot of hacky ways to go about it. There's not necessarily one right way to kind of do this, but just know that this is the main problem that people try to avoid when kind of doing these conversion problems. They try to make either this library method super extensible, or they try to make their data types very extensible so that they just kind of integrate really nicely with each other, and you don't have this kind of versioning or proxying work that you're doing here. So with that out of the way, so like I said, now we kind of have this code here that is very generic, has nothing very specific to do with names. In fact, you know, we'll kind of quickly go through here and change all of this. So array of strings. And then I'll give it just a generic name like this. Okay, cool. So look, and so just like that, you know, we've fully genericized it. This doesn't even look like code that belongs inside of names parser. So let's just think about maybe pulling this completely out and pulling it into a new class all by itself, so that some other stuff could use it in the future. So we're gonna come up here on our UI, and I'm just gonna make a new class here. And this is just gonna be kind of, you know, you'll see all kinds of stuff. I'm just gonna call it helper. I hate helper classes. I always think that always think functions need to live inside of, you know, something relevant, so, or some library. So this string code that we've written that adds a new line at the end of every string and all that stuff, that should probably be just a part of some extensible string library that you're building yourself. And so then you can kind of make a library called stringlib, and then that's just a method inside of stringlib, part of a class that's like array interfacers or something like that. So but I don't like the idea of a helper class, because it can just become a dump file for a lot of stuff and confuses people, and people don't really know how to use it all the time. They don't know like a clear line of what should go inside of it, and even how to refactor it can become super difficult. Because imagine making unit tests, and your unit tests are testing string concatenations and registry calls and certificate uploads. Like, it can be really daunting to work inside of a class like that. So be very careful making something like this. But this is a tutorial. This is just kind of a run through experiment. So we'll do it for now and just see where things land us. So what I'm going to do is I'm just going to, with the help of my compiler, I'm just going to go ahead and pop this code here. And we'll just kind of start to see what starts to break. So if I close out some of this. So when we come back here to names parser, first thing that fails out is our function here. We no longer have access to a join with new line. So the first thing I might say is, oh, well, I'll just call helper. Helper.join with new line, right? And has full access to helper. I F12 and I arrive there, but I still have squiggly on that call. Well, that's just because it is not accessible to its protection level. So I pop into here and a few options here, but we'll use public and just say that, hey, anything that's using this namespace can use the helper function. So our names parser exists in that namespace, so it has access to it. And here we go. We are good. We're resolved. Our unit tests are passing. So just like that, it was that easy to move some code that was well written, super extensible. So like I said, we had a very generic data type up here of strings. So it was very easy to move that somewhere else into a completely different class and then call it inside of names.parser so that we could use it. And now, we've progressively been making our code smaller and smaller, but just like that, we've actually shrank a little bit of the blueprint on this code. So you could, like I say, always take it as an experiment to go back after these videos, look through this code, see if there's more stuff that you can optimize away, because maybe something in here, you're like, well, this is the extraction code and I can see, this whole dot split on a new line. That's something that could be genericized a bit more and, delimited, and I can, you don't have to have this for each loop that's adding it all to a list. So it seems like that's a generic string, taking a string, taking a delimiter, and give a list data type that you want to output, and you're good to go. So, that's certainly one way to move on that. And please let me know what you end up doing with that. Feel free to kind of contribute and show your results. I don't know if I'm going to have a forum for this eventually, but I would definitely love to see what people come up with on ways that they might refactor out some of this code into other areas. And I don't mind giving feedback. So, but yeah, that's pretty much that. So just to kind of recap, what we did was we changed out, and I can come back to making something faster. So this was the state of the code before. Like I say, not a huge refactor, but we saw that, hey, we could genericize this. All this thing is doing is adding a new line to the end of a string, right? And our name is, it's really similar to a string, but it's not quite a string. So, but, it's really easy to convert name to a string, and we could genericize out this. So we made it into a method. I accidentally closed it. We made it into this method called join with new line. And like I said, now it can take any array of strings and join them all together, make a new line, and then spit them out to us just how we want, so that we can eventually just write them all to a text file. So we came here and we relied on it. We now rely on this new helper method to join everything with the new line. But the trade-off was that we had to do some conversion work to turn the list of names into a list of or array of strings. And as we saw, the trade-off on that is that you now have this new allocation of memory that is going to sit on your stack, and it really limits the size of the input or the output in this case that you can have, because you wouldn't want an array of millions and millions of names to go through this kind of code. You wouldn't want to copy all of that into memory. especially if the names, and in this case, names is actually pretty small, so that might not be that big of a hit. But you could imagine really long entries. Like there's nothing saying that this couldn't just be a document, right? So maybe court cases or something, and every name is a court case. And so you can imagine how big a court case is. And if you have millions of court cases stored in your database and they're all just kind of delimited by a new line in your database, because who cares about the readability of it in a database, then yeah, that would make this code super, super expensive, and it would take a long time to run. You'd have really high VM costs. So it's, this is a great area, like I said, to come back to figure out how you would optimize that away. We talked about the idea of using an array of objects instead of an array of strings for the parameter. And we also talked about using parameters for it. We also talked about overloading the toString method of one of the structs. So kind of a couple of different variations that you could do, all to fit your needs, but all of them pretty much are motivated from trying to avoid doing something like this. So, all right, that is everything. So the next thing we'll be talking about is just removing code, and that will be the last video in the series. Can't believe that. So, but yeah, thanks a lot for tagging along if you've been watching, and yeah, I'll catch you back next time. Bye.